Hello everyone, my name is Brandon, and for this project I decided to go with the paired sample t-test for my presentation. So in this presentation I'm just going to go into what the paired sample t-test is, and then basically how to use it in the SAS software, and then just go through the output of what the numbers mean when we run the code to conduct the paired sample t-test. So before we get into being able to do a paired sample t-test, our data sets need to um, uh, have this requirement for the data. So they must be continuous dependent variables. The data set must be within a related sample or group. The random sample of the data must be from a population. And then there can't be any outliers in the difference between the two related groups. So once your data meets this requirement, then you can confidently move on to conduct the paired sample t-test. So what does the paired sample t-test tell us? What does it test? Well, it tests whether the means of the two dependent data samples vary from each other. So its measured values are in pairs, and basically this test will tell us if there's a change from the first object to the next. It can also depending on your data set, it can tell you the difference between two time points, the difference between two conditions, two measurements, or just between a matched pair. In our case, I chose to do the data set with student scores and seeing if a professor's study program improved the scores of their students pre and post test. So we are given, the students take a test before going through the professor's study program, and then after going through the study program they take the test again, and then the pre-test and post-test scores are stored. So now we are going to hop into the SAS software and kind of just walk through how to use the SAS through our paired sample t-test. So this is just a web-based software. There is a desktop version, but I am using the web-based version. So to be able to start coding and getting our data, we're just going to click this hamburger up here and then go to develop SAS code. Cool. So now we're within the environment, and much like R, we have our section over here to be able to run our code, and then in this section over here, this is where our data is all going to be output. So I'm just going to walk us through kind of how this process works. So to set up the data, we are just going to store our data within this variable here, and then for the nice table over that is going to end up popping up, we're just going to have a pre and post test column, and then this here is just going to make the table look a little bit nice. So SAS does have preset data that you can find over in these side menus over here, but just to show you that you can input your own data into this and be able to just store your data into a data frame. That's why I'm just hard coding those in there, and then to be able to visually see our data set, I'm just going to set that up. Oops, I accidentally put scored, but that's fine. Cool. So now we're going to go over here and click run. And then as you can see, we are outputted this nice data table showing us our observations, and then again from here our pre and post test scores. So now we're just going to get into the paired sample t-test itself. So this is the line that will kind of do everything for us. So we're just going to use our test scores variable, and then we're going to set our alpha value to 0.5. And then we are going to do some math by multiplying our pre and post test scores, and then we're just going to have our run command there. and then we're going to go ahead and click Run again. Awesome. So as you can see, we still have our data frame up here, and then all of the numbers from our t-test thing that we ran right here, all the values, and then in each we are given some really nice visuals. So now I'm just going to walk us through kind of what each of these numbers mean for us. So the n here is just going to show us the size of our data sample. So we were sampling 15 students, and then the mean and standard deviation here are just giving us the average difference between a student's pre-test score and post-test score. So we can see here that the average score between a student's pre-test and post-test was 2.33. And then getting over here into the minimum, this minimum just shows us the smallest difference observed within the data set of the score difference between a student's pre and post-test scores, and then again in the maximum the same thing. So the minimum that we saw was 6 of a score difference, and then the maximum that we saw was 5. And then this is just our confidence intervals here with the 95%, and then our p-value here, which is 0.01, which is a good sign. So since it's below 0.05, we can say, we can reject the null hypothesis and confidently say that the difference between the pre and post test scores were significant enough to be able to say that his study program worked. So now walking through each of these visuals, this histogram shows us many things. So it's a histogram paired kind of with this box plot below. So in this histogram, this solid line here is just the normal distribution. And then the dotted line shows us our kernel density estimate. So it's a type of approximation. And so basically, if the scores were perfectly normally distributed, it would match up very nicely with our normal line, but as we can see, it is not. And then within this box plot, we can just see that this solid line shows us the median, while this diamond here shows us the mean scores within the pre and post test score differences. So now next is our paired profile line plot. This one's pretty cool to be able to visualize really how much the pre-test and post-test scores differed. So over here on this side, we can see our pre-test scores of our students and then our post-test scores of the students. So each one of these lines is going to be a student's scores, and then it just maps it from their pre-test score to their post-test score. So we can see this student here scored pretty low on their pre-test, and then going into the study program, they scored a lot higher on the post-test. And then we can kind of see that pattern reflecting across many of the students with some acceptances here. And then this is just the agreement of the post and pre-test score here, with the dots representing our mean scores between the students' pre and post-test scores. And then we are having over here the QQ plot difference between the pre and post-test scores given there. So yeah, that's SAS and kind of how to walk through inputting our data, running the paired sample t-test, and then all of the data and information we are given out there. So as we saw, just kind of recapping on our results outputted within SAS, here we were inputting our code to be able to nicely put it into a table here for our data frame to be able to run the paired sample t-test on. And then here, this was the line that did all the magic for us, the paired sample t-test. And then from this, we were giving all this data along with all of those graphic visuals that you saw that I walked through. So in conclusion, Yeah, the paired sample t-test is just a great test when you're needing to prove the improvement of an initial stage of data set to its new form. So again, it can kind of just test the differences between two time points, two conditions, two measurements, or a matched pair. So in our example here, we were able to prove that the professor's study program really did improve the test scores of his students. So now he can just kind of continue on using that study set. So that concludes my presentation. Thank you.